Welcome to integrals involving trig functions. So recall we have already seen a few trig integrals. So we have already seen that the integral of sine of x dx is negative cosine of x plus c. The integral of cosine of x dx is equal to sine of x plus c. And then in the last video, now that we have u substitution, we have also seen that the integral of tan x dx was equal to the natural log of the absolute value of secant of x plus c, which is equivalent to negative natural log of cosine of x plus c. So we already have these trig integrals. So now we're going to go ahead and take a look at the integral of cosecant x dx. So I have here a claim that this is actually equal to negative natural log of the absolute value of cosecant x plus cotangent x plus c. And we're going to go ahead and just work that out here. So this requires a slightly strange trick. If I want to find the integral of cosecant x dx, this is equivalent to multiplying by the fraction cosecant x plus cotan x, both up top and down below. So this is equivalent to cosecant x times cosecant x plus cotan x all over cosecant x plus cotangent x dx. So all that we have done here is we have multiplied by equivalency to 1 of cosecant x plus cotan x over cosecant x plus cotan x. Now this looks slightly strange, but if we multiply this out, up top we have cosecant squared x plus cosecant cotangent. So cosecant x, cotangent x. And then down below, we have cosecant x plus cotangent x. Now, the reason we have done this is up top, cosecant squared is more or less the derivative of cotangent, and cosecant is more or less the derivative of, cosecant cotangent is more or less the derivative of cosecant. There are negatives involved, that's why I'm saying more or less. So what we're going to do is we're going to set u to be equal to that denominator, cosecant x plus cotangent of x. Then we get that du is equal to, cosecant goes to negative cosecant x, cotan x, and cotangent x goes to negative cosecant squared x. And that whole thing is multiplying dx. So that numerator that we have are cosecant cosecant squared x plus cosecant x cotangent x is simply equal to negative, that times dx is equal to negative du. I just reordered the terms and then divided the whole thing by a negative 1. So what we wind up getting then is that our integral of cosecant of x dx is equal to the integral of 1 over u times -1 du, or negative the integral of 1 over u du. From here, the integral of 1 over u du is a natural log of absolute value u. So we have negative natural log absolute value of u plus c. Plugging back in our u, we have negative natural log of cosecant x plus cotangent of x plus c. So negative, the integral of cosecant x dx is the negative natural log of the absolute value of cosecant x plus cotangent x plus c. So from here, again, let's just go ahead and run through all 6 of our trig functions. So integral of sine x dx was again negative cosine of x plus c. We saw that briefly at the beginning of this video, as well as prior to this earlier in the course. Integral of cosine of x dx was sine of x plus c. Integral of tangent of x, we had 2 forms. This was either the natural log of the absolute value of secant of x plus c, or negative natural log of the absolute value of cosine of x plus c. The integral of cosecant x, we just found this was negative natural log of the absolute value of cosecant x plus cotangent of x plus c. Secant wound up being the natural log of the absolute value of secant of x plus tangent of x plus c. And then cotangent, integral of cotangent dx winds up being the natural log of absolute value of sine of x plus c. So those last 2 integrals you could work out using similar tricks as what for integral of secant, use a similar trick to what we used for integral of cosecant. And for cotangent, we would use a similar trick as what we used to the integral of tangent. Just a quick comment, beyond these integrals, we can also play around with trig identities to try to get integrals that we are comfortable working with. So just a note. In addition to these integration facts, trig identities can come in handy. Sort of using a mixture of these integration facts and trig identities, you'll be able to integrate a variety of powers of trig functions, but those will be done in Calc 2. So you will play around with these in Calc 2.